Jonathan,
Julian.
so excited for this topic because I know generative AI startups are definitely, at least I talk to startups, so anything startups for me, I get excited about. And I know that this is something that they're really excited about, particularly. But we've got people who are listening from all parts of the world, different levels of experience with AWS. So for those who aren't familiar with Amazon RDS, how would you describe what that is?
I'd say Amazon RDS gives you a choice of how you want to run your relational databases and makes it very easy to manage. So way back when I started with Postgres, which believe it or not was about 20 years ago, whenever you want to provision a database, you'd have to have your own hardware, or maybe you had a virtualized instance, but you'd have to set it up, you'd have to manage it, you'd have to set up your own monitoring. Hopefully you set up your own monitoring, you have to set up your own backups, et cetera. But Amazon RDS just makes this easy across the board for Postgres, MySQL, MariaDB, in terms of the open source engines, and SQL Server and Oracle as well for commercial engines. And it's great because I actually come from an application developer background, and as much as I love like writing SQL queries, I accidentally had to learn how to manage my database. I was more interested in just building out applications. So having something like Amazon RDS just to allow me to focus on building apps as opposed to managing the database, certainly makes it a lot simpler.
Yeah. I love that. Yeah. And there was a question that came up and I wanted to call that out. And I know Sydney was going to say something, but someone was asking here if they can ask questions. And yes, please do. That is why we do this live. The questions are really going to be focused on what the topics are. So today being on Postgres and specifically with this announcement of pgvectors and the next one being on Amazon Aurora. So if we're not able to answer your question, there is AWS Repost. It's a fantastic resource to be able to ask your questions and have them answered by the community if we're not able to answer it today. But as you're listening to us talk, please ask your questions. I'm going to be moderating the chat so I can see what is being asked and make sure that if there's a question here that's relevant that I know other people are going to want to hear about, we'll make sure to address it. And then Sydney, I know you were going to say something.
No, I was going to say, awesome. Thank you for the overview of RDS. And so I think it's a great segue into what you're talking about today. Can you tell us a bit about the new extensions and how they work in Amazon RDS?
Sure. So maybe a general question. Are you familiar with extensions in Postgres? Because I think those in themselves are, kind of the magic.
I know I'm not. Yeah, but are you?
All right, let's dive in. So Postgres is, an open source database. It's been open source for actually almost 30 years and has, close to 40 years of development behind it. I'm actually involved in the upstream project. I'm on the core team, which is responsible for general governance, but really, there's a whole community of developers just working on it. And from the start, Postgres was designed to be extensible. And what does that mean? So it's open source. So if you want to build your own database or add functionality, you can take the code, fork it, copy it, do your own thing. But then that means that you're running individual distributions of Postgres in different places, and that can get hard to manage. So there's this thing in Postgres called the extension framework, which allows you to add functionality to Postgres without having to fork it. And you can basically create these little packages, or in some cases, very big packages that add additional functionality into Postgres and effectively let you run it anywhere. So on Amazon RDS and Amazon Aurora today, I think there's close to 90 Postgres extensions out of the box. We actually open sourced at reInvent last year something called trusted language extensions, which lets you write your own extensions in trusted languages like JavaScript, which we have available on RDS and Aurora. Package them yourselves and then run them anywhere. So it's a really cool thing. And the reason I wanted to get that overview before we dive into pgvector today is just to talk about really what attracts developers to Postgres is that you can just add functionality to Postgres and you don't need to run your own distribution of it. It just works in RDS and Aurora.
Sounds very powerful.
Yeah.
That was a great overview. I'm sure a lot of people thought it was helpful. I know I thought it was. No one's an expert in anything. So maybe with that, maybe you can talk more about pgvector specifically.
Yeah. So pgvector is interesting, and maybe can I share my screen real quick because I want to show you something. So this is a graph. This is a website that shows the number of stars that you see in projects in GitHub. And if you look at pgvector, you can see that it was open source in about 2021. And you can see that it was growing. People had to use to store vectors in Postgres, and we'll talk about what that means in a second. But there's this inflection point, and suddenly you see this growth. And in the startup world, you're probably familiar with hockey stick growth. I mean,
Yeah.
this is beyond hockey stick growth. This is like factorial growth. Like I've only seen this in, my algorithms class back in college. And, you can see like suddenly like there's this strong desire to store vectorized data in Postgres. Now, I think that in itself is kind of a loaded term. Like, what do you mean like store vectorized data in Postgres? Well, vectors, it's a mathematical concept. They've been around not since the dawn of time, but pretty early on. I think there were some formal definitions in the early 1800s. And vectors are a very powerful component in machine learning and artificial intelligence systems. What a vector can do is that it can represent an attribute set, or effectively, let's say, let me step back. Like, let's say I have a cat, right? I have a cat with sunglasses. Let's say I want to search for like what a cat with sunglasses is. Well, how do I translate that into a way that a computer can understand it? I need to make a mathematical representation. And that's what these vectors ultimately are, is that when I say like, cat with sunglasses to a machine learning model, it takes that, it turns it into a vector and assigns a bunch of different attributes to it. Then, I want to find other cats with sunglasses. I need to do, different kinds of searches to do that. And a popular one is something called a vector similarity search, which helps you to find, your nearest neighbors or your closest vectors to it. So with all that in mind, what does pgvector do? pgvector brings that functionality to Postgres, where you can store vector data, build indexes on it, which help you to speed up search and speed up like these vectorized searches. And then you can find your nearest neighbors in that way. Now, Postgres already had functionality for this, believe it or not, for about 20 years, that there was a way to store vectors and do searches on them. But either there was some missing functionality in terms of not having the right distance functions to be able to find, what are my two closest vectors, or it was limited to 100 dimensions. And with a lot of these new AI ML models coming out, you're seeing things that are like 256, 512, 1536, and even numbers like, I saw something that was like 80,000 dimensions, which like I still can't imagine, what that is in my head. So this is why, we saw this, and, seeing how our customers want to be able to, take their existing applications in Postgres and integrate these new AI ML systems into it and keep all their data in one place, led us to want to be able to add support for pgvector to RDS today.
Yeah, I love your explanation. And I mean, this chart is just absolutely astonishing to really see the demand. Obviously, with generative AI, it definitely correlates with the demand for building generative AI models. And then now with pgvector, it's the timeline's very clear, I would say, from this chart. And I loved your explanation of it. Are there any other maybe benefits or use cases that you're seeing really with pgvector and specifically with RDS Postgres?
Yeah, so that's a great question. I mean, clearly, as you said, generative AI, there's a huge trend to it right now, and in particular because of its accessibility. As I mentioned, vectors are, mathematical representation. There's a lot of different things you can do to calculate similarity. So, one application you might see in the geospatial space, where effectively when you're storing coordinates, that's a vector, and you can use this to perform similarity searches between those. Now, Postgres already has an extension for a lot more robust geospatial processing, PostGIS, which is also available on Amazon RDS and Amazon Aurora today. But just thinking, basically anything where you have an array of data or, any kind of application where you might have vectors like, physics and mathematics, you can use this to, be able to do those kinds of searches.
That's very interesting. And it sounds very powerful. Like pgvector, how does it work with any like other recent AWS AI innovations, if applies, like Bedrock or SageMaker?
Yeah, it works very nicely. And the reason is that, vectors are the lingua franca of AI ML models. And I'm kind of saying that because as I've been going on my own personal journey with Postgres, I've seen all these different workloads evolve over time. Back 15 years ago, everyone was looking out for a way to store JSON data from web applications in their database, and Postgres ultimately added support for that. Now we're seeing that with the accessibility of machine learning models, even those from Amazon SageMaker, it makes it much easier to take that data, store it somewhere, and reprocess it or search over it offline, as they like to say, and it helps to make that transition much more seamless. In fact, I don't know when we're going to get to it, but I do have a demo showing how we can use pgvector to store data from an Amazon SageMaker run, and then later go through that output.
Awesome. Yeah, let's see it.
Cool. All right. So I will, full disclosure, there's going to be a little bit of Julia Child here, where we're going to put the pie into the oven, and a minute later it's going to come out baked. So we're going to talk a little bit through this Jupyter notebook. Now, I'm going to make a confession. I've known about Jupyter for years. Jupyter is a way for you to run code in line and see the output, and it's a great data science tool. But this is the first time I've actually used Jupyter for real, and in part it's because SageMaker made it so easy to use. Like, it took care of all the setup, and all I had to do was just go through and click, 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 and create the notebook. So I'm going to step through this a little bit, and then we're going to get to the really cool part of the demo. What we did is, initially we set up the prerequisites to install the necessary Python libraries to be able to run the experiment. And well, maybe I should back up and say what the experiment actually is that we took a data set of clothes available, because everyone likes clothes. I mean, I typically, shop very simply, and I wear effectively the same shirt every day. But for other people, they want to be able to search and find clothes. So we took this data set. We stored it in S3 buckets so SageMaker could find where the data set existed. And then we built out a data model using the Hugging Face model to be able to, basically learn and make predictions over this data set. And what I mean by that is that's where we're going to ultimately generate the embedding. So the machine learning model, effectively, it's like going back to the cat example. It's that we have a cat with glasses. We need to find a mathematical representation for the cat, and we send it up to the machine learning model, which is going to look at all of the data and generate those vector embeddings. As it goes through and it generates those embeddings, it's going to try to effectively find what they say is the best fit for them. So that way it's as close to an accurate representation as possible. So that took a little bit of time. I think to generate all of that, it took about 9 minutes. That's the pie in the oven. And what we get is, from our output is that we got a list of about 8,000, I think it was 8,000 articles of clothing. And the vectors are of a dimensionality 384 dimensions. So again, this is where pgvector is going to come in, because we need a place to be able to store these vectors. And these are much larger arrays of data. Normally, like I said, normally we think in 2D and 3D. 3D is the objects all around us. So this is 384D. Again, it's a mind-blowing total. And you see, some of these LLMs, the dimensionality is gigantic. It's just so hard to visualize. I like to joke when I was in college studying machine learning, which, believe it or not, was a while ago, 20 dimensions was considered high. So it's really mind-blowing. But let's dive into where pgvector is and where it fits into this. So we've generated all this data. We have close to 9,000 vectors, and we ultimately want to build a search application over them. And again, this is where we're seeing a lot of startups and established enterprises looking to do with these AI and LLM models. So here's a very basic script that we're going to start running. And what it's going to do is that it's going to connect to an RDS Postgres database. It's going to add the pgvector extension to it. And we're going to load all these vectors, all these vector embeddings in a table called products. Now, for the astute observer who's looking at this, they're going to see that the way that we're bulk loading the data is actually fairly naive. We're looping over a bunch of insert statements. Normally, you would do a bulk load of this information. So we see that we see the vector embeddings have been loaded. It's going to now create an index on it, and we're going to do a little bit of statistical prep work to make sure that it's ready to go. And now we're going to run some searches. So normally, we probably would do this from a fancier web application interface, but it's still pretty cool from a Jupyter notebook. So we're going to look for a red sleeveless summer wear, which is something that you type into a search engine. So let's click run and see what happens. Here we go. Red sleeve. I mean, this looks like red sleeveless summer wear to me, right?
Yeah.
Very.
So how about we vary it a little bit? Let's do yellow sleeveless summer wear. There you go. And that's really cool because basically
Yeah.
we're taking this text and we're able to match it against, this whole set of images that we have. And that's, it's quite magical. And I want to just jump over to a code terminal real quick so we can see what happened here. So even though there's these wonderful graphical user interfaces for working with your database, I still use a terminal. I can't help it. So we have a table. It's called products. This is where all of our products live. If we inspect this table, we can see, this is mostly no tricks up my sleeve. It's exactly what we think. And we have this field in it called descriptions embeddings, which is where we're going to be searching over, all the different types of clothing we loaded in. And so this vector type of 384. So it's 384 dimensions. This is what pgvector gave us. And what we're going to do now is we're going to see what it looks like to actually run a query against it. So I had preloaded a query somewhere over here because these vectors are pretty long. And let's scroll down. So we can see that, let me just, so we can see that, after I warmed the cache up a little bit, it took 1 millisecond to execute. So normally what happens with these distance queries is that there's different distance metrics, and they can be, fairly intensive from a calculation standpoint. Now, because of that, we want to be able to minimize the amount of time we do those calculations, because effectively, if I were to search the entire, 9,000, set of rows, and then I have to do that distance calculation every single time over 384 dimensions, it adds up. It kind of looks, like that graph we saw with, everything all the time going up there. But with the index, I'm able to do this, very quickly, and I'm able to get back a result, in less than a millisecond in this case. Now, this is a fairly small set of data, and we've done experiments with much larger sets, and we'll see comparable results where we're getting, answers within, a very short amount of time. So that's the power of pgvector right there. And there's all sorts of, this is a very deep topic in terms of vector search. We probably could spend another 30 minutes discussing all the nuances and future direction, everything in that space. But the takeaway that I want people to get is that if you have existing applications running in Postgres and you want to integrate these newer AI ML models into it, there is a way to do that with the pgvector extension, and you can do this today on RDS for Postgres and integrate it into your existing applications.
John, this demo was just so fascinating. I know now there's so many people who are really learning about generative AI, or they're starting to apply it really for the first time. So they're probably watching this demo and they're like, oh my gosh, I want to be able to follow along and go through it again. So fortunately, for those of you who are new to AWS On Air, all of these recordings are going to go on YouTube. So fortunately, you can watch this again and listen to Jonathan's explanations about this. So you'll definitely want to check out the recording again of this. But this was fantastic. So Jonathan, where can people go if they want to really learn more about pgvector on RDS Postgres?
Yeah, so there's a few places. First, I do recommend going to the open source project. It's on GitHub. It's like pgvector/pgvector on GitHub, as has been posted over there. And and please spin up a RDS for Postgres instance and try it out. I mean, I think what's really fascinating right now too is machine learning itself, AI itself. It's not a new concept. It's been around for a while, but the accessibility of it has grown. And I keep hitting on that word. That's just so easy for anyone to become a machine learning expert in a way. So we want to see what people are building, because what's great about pgvector being open source is that this is a project that we want to contribute to, and we want to encourage others to contribute to as well. And all the learnings we get from what people are doing are just going to help us to make pgvector better and make it easier to manage your AI ML workloads, at least the data you're storing from them directly within Postgres, whether it's on Amazon Aurora or Amazon RDS.
I love it. Yeah. Go ahead, Sydney.
No, very neat. Thank you for sharing this with us. And this is something I'm going to bookmark to look at later myself. I've had such an interest in AI ML lately. It's all the rage lately, right?
Yep.
So thank you for this demo, and thank you for coming on today.
Yeah, thank you.
All right, perfect. Thanks so much, Jonathan.
Thank you, Jillian. Thank you, Sydney. Thank you, Brian and Jasmine.